Hello everybody. Today we're going to solve systems of linear equations in three variables. Now we've done it in two where we had a y and an x. Now we're going to add a z. That's our third variable. Since I have three variables, I need three equations. Okay, just due to the length of the problem, I'm going to show you how to do it. We're just going to do one example of each because they are fairly long, involved problems. Okay, here we go. First one we're going to do, we want to solve this system by substitution. Again, notice there's three variables, therefore I have three equations. Now you want to pick variables that are going to be easy to solve for. You need to solve for the same variable twice. You need to solve for the same variable twice in two different equations. Okay, so just looking at things here, I think I'm going to solve for y in these two equations. Okay, well, let's go ahead and do that. If I solve for y in this one, in the first one, I end up with y equals negative 3x. I subtract that over, plus 2z plus 10. Okay, now I need to solve the second one for y. So that's going to leave me with negative 2y equals negative 6x minus z minus 2. Divide everything by negative 2. It gives me a positive y equals a positive 3x plus z over 2 plus 1. And I divide by negative 2. So now I've just solved the same two different equations for the same variable. Now I need to plug this one into a second equation, so I'm going to use this last one here. Okay, because I need to get everything down to two variables. So if I plug this in for y, okay, we're doing it in the green here, I get x plus 4 times the y, which is negative 3x, plus 2z plus 10. Again, same as it was with two variables, except now I just got more variables to deal with. And I still have my 3z equals 7. Okay, well, let's go ahead and solve x minus 12x plus 8z plus 40 plus 3z equals 7. Okay, let's get all my x's together, all my z's together. I have negative 11x plus 11z plus 40 equals 7. Now if I subtract my 40, I get negative 11x plus 11z equals negative 33. Correct? Now I could divide everything by 11, and that'll simplify things. That leaves me with negative x plus z equals negative 3. Now hang on to that because you're going to need it here in a second. Okay? That was plugging in the first thing I solved for y. The first equation I solved it for y, I plugged it into the third equation. Now I need to substitute in a second combination, and that is why I solved the second equation for y. And I picked y because it looked easiest to me. You don't have to do y first. Okay, but I'm going to plug y into the third equation as well because that's a different combination. If I label these equations let's not do 1, 2, 3, let's do ABC. I need to substitute the same variable in with a different combination. Well, I used A and B, so I can't use that combination anymore. Or A and C, excuse me. I used A and C, so now I'm going to use B and C. That's a different combination, so it's going to end up with a different equation when I'm done. Let's just go ahead and go through it so you can see. So I have x plus 4 times 3x plus z over 2 plus 1 plus 3z equals 7. Okay? Let's go ahead and keep solving. So x plus, I got to distribute 12x plus 2z. 4 times 1/2 is 2, plus 4 plus 3z equals 7. Okay, let's get like terms together. 13x plus 5z plus 4 equals 7. 13x plus 5z, and I subtract the 4 equals 3. Well, now I have two very different variables, but look what I've done. Now I have a system of equations. I have two equations left, okay? 1, 2, with two variables, and they're both x and z. So now I do what I would normally do with a normal system. Now I'm going to go ahead and solve for one. Well, if I look at these two and look at them independently, it looks like z is going to be the easiest variable to solve for. And I'll substitute it into the other side. So z is going to equal positive x minus 3. Okay? Well, I'm going to take this and I'm going to plug it in for z in this second equation. That's going to give me 13x plus 5 times x minus 3 equals 3. Okay? Well, 13x plus 5x plus 15 equals 3. Okay, well this gives me 18x equals, oh, this is a negative 15, equals 18. I finish x equals 1. Okay? Now, I have done all that work just for the one variable. I need 3. I have an x, y, and a z. So that means I'm going to have, I'm going to have 3 variables to my coordinate, x, y, and z. Okay? We'll have to go back through and solve. Well, let's make this easy. I know x is 1. Let's just plug it in for x here, and I'll figure out what z is. Z is 1 minus 3. Well, that means z is negative 2. Okay? Well, now I know what x is and I know what z is. X was 1, z was negative 2. Now what I'm going to do is plug that into an original equation from up here and solve for what's left. I need a y, so I'm going to use this one. I'm going to use this one because it's already solved for y, and I just need to plug numbers in. Okay? Well, let's rewrite this down here where I got a little room. Okay, y equals negative 3x plus 2z, I believe, plus 10. Okay, I know x is 1, I know z is negative 2, so y equals negative 3 times 1 plus 2 times negative 2 plus 10. Solve it. Y equals negative 3 plus negative 4 plus 10. Y equals negative 7 plus 10. Y equals 3. So when I'm done, my answer now is the x, the y, and the z. And that's the substitution method. Okay? Well, let's take a look at the elimination method. The elimination method. Again, if we label these things A, B, C, we need to get rid of the same variable using two different combinations. Okay, well, I'm looking at that thinking that probably y would probably be a good variable to get rid of. Or x. X doesn't look like it would be too bad. But I'm going to use y again, and it's just coincidental. Okay, so if I'm going to get rid of y in these top two, I need to multiply the top equation by 3 and the bottom equation by 2. So I've got 4x plus 2y plus 3z equals 1. I'm going to multiply this one by 3. And then I've got 2x minus 3y plus 5z equals negative 14. I'm going to multiply this one by 2. Okay, well when I do that I end up with 12x plus 6y plus 9z equals 3. And when I multiply the second equation I end up with 4x minus 6y plus, oops, got ahead of myself, plus 10z equals negative 28. Now we add up just like normal. Okay, we're just getting rid of one variable. So I add these up, I end up with 16x plus, it's like 19z equals negative 25. Can't really do much with that. That's okay. Now I need to get rid of the y's using a second combination. So I'm going to use these bottom two. So all I have to do, I keep the top equation the same. Equals negative 14. And now I've got to multiply the bottom equation by negative 3, because negative times a negative is going to give me a positive 3y. So negative 3 times 6 is negative 18x plus 3y minus 12z equals positive 3. Okay? Well, now we add these up, and I end up with 16x minus 7z equals negative 11. Okay? Well, now oops, this is a negative 16x. Well, now I look at this, and this falls out pretty nice for me. This falls out pretty nice for me, because now I got two equations with just two variables. They're both x and z again, just like the last one. But now I need to eliminate a variable. Well, if I look at this, it's already done for me, because I already have a negative 16x and a 16x. So let's just rewrite the green equation over here. I got negative 16x minus 7z equals negative 11. And let's just go ahead and solve, because that's going to be 0. When I add them up, 16 and negative 16 is 0. Plus 12z equals negative 36. Okay, well, I divide, and z is going to equal negative 3. Okay, now again, this one I ended up with z as the first variable I solved for. The other one was x. Just do what's easiest. Don't make it hard. Okay, they're long enough as it is. Try and pick easy variables. Okay, well, let's go ahead and finish this up now. I need to plug back in and get something for x now that I know what z is. So let's just use this. Negative 16x minus 7 times negative 3 equals negative 11. Okay, well, negative 16x plus 21 is negative 11. So I subtract the 21 over, I get negative 16x equals negative 32. So x is a positive 2. Okay, well, again, now that I have all those solved for, I need to plug it into an original. So I'm going to rewrite the bottom equation. Doesn't matter which one I use, I'm just going to use one. So 6x minus y plus 4z equals negative 1. Comes from right here. And I'm going to plug in what I know, because now I know an x and a z. So 6 times 2 minus y plus 4 times negative 3 equals negative 1. 12 minus y minus 12 equals negative 1. Look at that. My 12s go away. So I have negative y equals negative 1, which means y equals 1. So my answer when I'm all done is 2, 1, negative 3. X, Y, Z. There's my answer. Okay? Now we'll get into special cases when you get to class. I do realize that this is quite a bit of work, but it's the same process that we're going through when we had two. It's just now I need to use two different combinations to get rid of the same variable. Okay? If you need to rewatch this, and you might, go ahead. Hopefully this makes a little bit of sense. We'll definitely work some more problems in class. We'll see you there.